copper rod of diameter 1 cm and length 8 cm is drawn into a wire of length 18 meters of uniform thickness. Find the thickness of the wire. Answer. Given dimensions of copper rod are diameter D1 equals 1 cm. This implies that radius R1 equals 1 by 2 cm, since radius equals diameter by 2. Length L1 equals 8 cm. As we know that the copper rod is in the shape of a cylinder, we have volume of copper rod V1 equals pi R1 square into H1. And the given dimensions of wire length L2 equals 18 meter equals 1800 centimeters. We need to find the diameter D2, that is, thickness of the wire, and also radius R2 of the wire, in order to compare the volumes. As wire is also in the shape of a cylinder, we have volume of wire V2 equals pi R2 square into H2. Therefore, volume V1, that is, volume of copper rod equals pi R1 square into H1. On substituting the values of R1 equals 1 by 2 centimeters and H1 equals 8 centimeters, we have pi into 1 by 2 square into 8. This is equal to 2 pi. Therefore, volume of the copper rod V1 equals 2 pi centimeters cube. And we have volume V2, that is, volume of wire equals pi R2 square into H2. On substituting the value H2 equals 1800 centimeters, we have this is equal to pi into R2 square into 1800. Therefore, volume V2 equals pi into R2 square into 1800 centimeters cube. Since the copper rod is converted into a wire, the volume of both of them remain same. That is, the volume of the copper rod equals volume of the wire. This implies that pi into R2 square into 1800 equals 2 pi. This implies that R2 square equals 1 by 900. This implies that R2 equals root 1 by 900. This implies that R2 equals 1 by 30. Therefore, the radius R2 of the wire equals 1 by 30 centimeters. Now, we need to calculate the diameter of the wire. The diameter of the cross-section of wire, D, is calculated as 2 into R. This is equal to 2 into 1 by 30. This is equal to 1 by 15. This is approximately equal to 0.67 millimeters. Therefore, the thickness of the wire is approximately 0.67 millimeters. Let us now see some exercise problems. 1. A metallic sphere of radius 4.2 centimeters is melted and recast into the shape of a cylinder of radius 6 centimeters. Find the height of the cylinder. Answer. Given that radius R1 of sphere equals 4.2 centimeters. Radius R2 of cylinder equals 6 centimeters. Let the height of the cylinder be h. The object formed by recasting the sphere will have the same volume. That is, volume of sphere equals volume of cylinder. This implies that 4 by 3 into pi into R1 cube equals pi R2 square into h. This implies that 4 by 3 into pi into 4.2 cube equals pi into 6 square into h. This implies that 4 by 3 into 4.2 into 4.2 into 4.2 by 36 equals h. This implies that h equals 1.4 cube. This implies that 2.74. Therefore, the height of the cylinder so formed will be 2.74 centimeters. 2. A 20 meters deep well with diameter 7 meters is dug, and the earth from digging is evenly spread out to form a platform 22 meters by 14 meters. Find the height of the platform. Use pi equals 22 by 7. Answer. Given that depth D of well equals 20 meters, diameter equals 7 meters. This implies that radius R of circular end of well equals 7 by 2 meters. Area of platform equals length into breadth equals 22 into 14 meters square. We need to find the height of the platform. Given that soil dug from the well is spread in the form of platform with some length, breadth and height. Assume the shape of the platform thus formed be a cuboid. We know that volume of the newly formed shape remains same. We have volume of soil dug from well equals volume of platform spread. Now, let us assume that the height of the platform equals h. As volume of soil from well equals volume of platform, we get pi into r square into d equals area of platform into height of platform. On substituting the values of pi equals 22 by 7, r equals 7 by 2 meters, d equals 20 meters, area of platform equals 22 into 14, and height of platform equals h, we get pi into 7 by 2 square into 20 equals 22 into 14 into h. This implies that h equals 22 by 7 into 49 by 4 into 20 by 22 into 14. This implies that 5 by 2. This implies that 2.5. Therefore, the height of such platform spread will be 2.5 meters. 3. A well of diameter 3 meters is dug, 14 meters deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters to form an embankment. Find the height of the embankment. Answer. Depth h1 of well equals 14 meters. Diameter of the end of well equals 3 meters. Radius r1 of the circular end of well equals 3 by 2 meters. Width of embankment equals 4 meters. From the figure, it can be observed that the embankment will be in a cylindrical shape, having outer radius r2 as radius of the circular end of well, plus the width of embankment, that is, 4 plus 3 by 2. This is equal to 8 plus 3 by 2. This is equal to 11 by 2. Therefore, outer radius r2 equals 11 by 2 meters. Inner radius r1 is calculated as the difference between the outer radius minus the width of the embankment. Therefore, inner radius r1 equals 11 by 2 minus 4. This is equal to 3 by 2. Therefore, inner radius r1 equals 3 by 2 meters. Let the height of embankment be h2. As volume of soil dug from well equals volume of soil used to form embankment. This implies that pi into r1 square into h1 equals pi into r2 square minus r1 square into h2. On substituting the values of r1 equals 3 by 2 meters, h1 equals 14 meters, r2 equals 11 by 2 meters, and h2 equals h, we get pi into 3 by 2 square into 14 equals pi into 11 by 2 square minus 3 by 2 square into h. Cancelling pi on both sides, and on simplification we get 9 by 4 into 14 equals 112 by 4 into h. This implies that h equals 9 by 8. This implies that 1.125. Therefore, the height of the embankment will be 1.125 meters.